substitute materials for river sand on properties of concrete. Myself, Mr. Chetanji Konapure, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Now, this is the learning outcome after this presentation. The student will be able to compare the properties of concrete with substitute materials for sand. Okay, now directly I am starting this with this table in which the study of properties of concrete started. Now there are 10 mixes. Now this is the experimental work I am presenting here, which was carried out in the laboratory, and for the river sand 25% is substitution, 50% substitution and 75% substitution. 3 substitution levels are tried, but internally there are 2 materials which are used, that is quarry rock dust QRD and MP is marble powder or granules. So 2 materials are substituted in this, and this 25% substitution it is divided in 2 parts. One is the part of quarry rock dust, second is the part of marble powder. If you observe this substitution, I will explain you the trials. First is 50% of substitution of the material, substituted material. So 25% substitution, 50-50 means 12.5 quarry rock dust, 12.5 marble powder. Now here if you observe that the quarry rock dust is improved, so 25% substitution, again it is divided into 2 parts, 75% quarry rock dust, 25% marble powder. Now 100% QRD quarry rock dust is used as a substitution, marble powder is 0. So in the last trial, quarry rock dust is completely made 0 and full 25% marble powder is substituted. In this way, the several trials are made. There are 10 concrete mixes. M is the river sand mix, 100% river sand mix, which is RS. And all category samples are tested and analyzed for the properties of fresh concrete, and the slump compaction factor, density and the compressive strength and flexural strengths are tested, and these are compared, and the study has been made. Now this is carried out on M20 grade of the concrete. So because M20 grade of the concrete is a nominal grade which is used in all types of residential commercial projects in nearby our area, basically only maximum M20 grade of concrete is generally used, and the proportion which is carried out in the laboratory, water cement ratio 0.5, fine aggregate 1.8 and coarse aggregate 3.5. Okay, now the table which is showing here is the table 1, in which slump and compaction factor of the concrete with different percentage of marble powder and quarry rock dust are explained. Now already I have explained you this 10 mixes, and the designation of the mix is SM 1, 2, 3, 4, 5, 6. SM means in which substitution is made, that's why it is substituted mix. M is the mix in which only 100% river sand is used. Okay, now let us see what are the results for fresh concrete results. So slump and compaction factor test both are conducted, and their results are noted here. Now if you observe for 100% river sand, the slump is 0.85 and compaction factor is 0.92. So this is medium workability which we have got. As the substitution of materials is started, now in the 25% substitution, if you observe the slump is reducing from 80 to 15, because the marble powder 25% means full substitution of marble powder is used, and the slump has reduced to 15, and the compaction factor also reduced to 0.81. So if you use marble powder, which is very fine powder, then the slump and compaction factor both are reducing. Let us go for the 50% substitution. 4 mixes are there from SM5 to SM8. Now if you observe, the slump has reduced from 85 to 35, and in which good slump we have got for this mix, that is SM6 and SM7. We have got the proper compaction factor also for SM6 and 7. What is SM6 and 7? In which 50% river sand, 37.5% quarry rock dust, 12.5% marble powder. So we can see here the marble powder percentage has reduced. That's why the slump has increased. And last is 75% substitution, in which 25% river sand is kept, 35% quarry rock dust is kept, 37.5% marble powder, but slump has drastically reduced, compaction factor also reduced. Now, if you graph wise, you can see here M, this is the compaction factor. Compaction factor is a real test which indicates the workability. So, lower workability is observed for SM4. What is SM4? SM4 is 75% river sand and marble powder. Full substitution of marble powder has given very low slump. Now, if you observe this compaction factor, it has improved to say SM8. SM8, this is very good. 50% substitution is good, and little bit the slump and compaction factor both are good in this case, SM7, SM8. Okay, now what is the discussion? So, percentage substitution for river sand is increased, the workability of slump and compaction factor has reduced. This is the general discussion which we have observed in the earlier result. For 25% substitution, SM1 has given medium workability and SM4 has given very low workability. So, we should isolate SM4 from 25% substitution. In case of 50% substitution, SM6 has given medium workability and SM8 has given low workability. So, SM6 is little bit good from slump and compaction factor point of view. Now, next point is density, because we are substituting the material. Powder material is there, marble powder is also there, quarry rock dust, both are in the part of powder forms. So, what will happen to the density? Okay, the same mixes are there, same substitutions, only the density is the result which is discussed now. If you consider the 100% river sand density 2410 kg per meter cube, and if you consider the next mixes, the density is little bit increasing, and very high density if you are observed, that is for SM8, in which marble powder is 50%. So, marble powder, which is a fine powder, which has increased the density 2760, which is the highest density we have observed. From this point of view, the SM8 mix is giving good density, even SM6 is given the good density 2610. Okay, now this is the graph which shows the workability versus density. This relationship is established. Workability means compaction factor is taken. Then for that, compaction factor for concrete with different percentage of powder, marble powder and quarry rock dust. And if you observe, low density is observed for 25% substitution, that is with substitution SM2 for that mix, and for 50% substitution SM6 is a good mix. Now, the relationship between compaction factor and density is plotted here. On y-axis compaction factor is there, on x-axis density of the concrete is plotted, and all the mixes with their results are plotted. M is having density which is low, very low density. M is 100% river sand, and these are the mixes which are very close to your result. So, it is in between 2550 to 2650. So, density is in between this range, and compaction factor is very low. So, SM4, 6, 3, 7, 5, 9, these are having very low compaction factor. If you go for SM2 and SM1 with higher density, very high compaction factor is achieved for SM2 and SM1. Now, let us go for the results of the hardened concrete. Here, if you observe, compressive strength at 7 day, 28 day is presented, and even the flexural strength is also presented. So, both three strengths are compared here, basically compressive and flexural strength. Now, all the mixes are having substitution here, the same table, but only the comparative point is strength. Here, if you observe the 7th compressive strength, 7 day compressive strength, 28 day compressive strength. For 100% river sand, 7th and 28 is 21.74 and 25.81 respectively. And your flexural strength is 2.23. As substitution started, 25% substitution, the strength has reduced. If you observe this, 27 day strength has reduced. Somewhere it is increased for this mix SM3, the 7 day strength is increased little bit, and 28 day strength is also increased. In 50% substitution, the strength has increased for this SM5, the SM6, but for SM7 and 8, the 7 day strength has reduced. Now, 28 day strength, it is very good in case of SM7. So, these strength variations are there, but ultimate strength is 28 day strength, which is a comparative point also. And that discussion, let us see the discussion of this table. As percentage substitution of marble powder increase, the 7th and 28th days compressive strength has reduced. So SM4, SM8 mixes in which the 7/20th day strength is reduced. So 7-day compressive strength for SM5 and SM9 is observed, which is very high, and it may be due to higher powder content of marble powder. Now next, in 25% substitution, SM1 mix gives highest 28 days compressive strength, and for 50% substitution mix, SM7 gives highest 28 day strength. If you want 50% substitution, go for SM7. If you want 25% substitution, go for SM1 type of mix. And the mixes with combined fine aggregate given higher compressive strength than the mixes with only river sand. So substitution is good from strength point of view. Only what percentage, that we have to decide based on the workability what we needed and the strength. Now highest flexural strength is given by both SM1 and SM7. So in case of substitution, you go for SM1, and if you want 50% substitution, you go for SM7. That is the key point of discussion in this entire study. These are the references which are used for this session. Thank you.